Welcome to this Frequency Matters podcast. I'm Pat Hindle, and I'm talking today with Paul Head, Director of Next Generation Technologies, Advanced Technology at Raytheon. Welcome, Paul.
Thanks, Pat. Appreciate you having me.
Raytheon recently won a contract to build high-power microwave systems for the U.S. military and successfully demonstrated the CHIMERA high-power microwave system during the field tests. Can you tell us about those programs that are involved in systems?
Yeah, I'd be happy to. So yes, we recently received a 3-year, $31 million contract. It came from the Naval Surface Warfare Center Dahlgren Division to design and build 2 prototype high-power microwave antenna systems for the U.S. Navy and the U.S. Air Force. This work that we're doing is part of the DEFEND program. DEFEND stands for Directed Energy Frontline Electromagnetic Neutralization and Defeat. The goal of this program is to use directed energy to defeat airborne threats at the speed of light. And CHIMERA was the Air Force's ground-based prototype. It's a standalone HPM system built as a technology demonstrator to fire highly concentrated radio frequency energy at multiple mid to long range targets. It really is the phase 0 for DEFEND program. We've been working in partnership with the Air Force Research Lab for several years now on CHIMERA. And the recent testing, excited to share the news about our recent tests out of White Sands. It's, as I mentioned, phase 0 of the overall DEFEND effort, kind of sets the stage for the new prototypes we're working on to DEFEND. We've also partnered with the Navy and the Missile Defense Agency to help make this technology successful.
And so Raytheon's been a leader in the use of high power microwaves for nearly a century. Can you talk a little bit about the importance of these systems and what you're doing to field the capability faster?
Yeah, as you mentioned, we've been working in microwave technology for many, many years. Really what we're doing here with high power microwave is using microwave energy in a different way. Folks are very familiar with how we use them today in our sensors and radar applications and our communication systems. But here we're using it as an effector. And with the current threat environment, we are seeing a driving need to continue funding these type of developments. Every new threat we see out there, airborne threats, they're reliant on increasingly complex electronics. And the way high power microwave works is it attacks those electronics and disables them and therefore prevents those threats from doing their job. During the last 5 years, we've seen a number of demonstrations that kind of show the viability and the cost advantage of using directed energy to counter these threats as opposed to kinetics. Our goal here is to develop and field these high power microwave systems ahead of our adversaries, and that way we're better prepared to deal with these types of threats. We at Raytheon have been investing in this technology for decades. What we're doing here is simply, as I mentioned before, a new application of the technology and how we're going to use it. One of the things that we're investing our own money in is looking at how to integrate these systems with all of the other existing systems out there today, our existing sensors and command and control networks to be most effective in a layered defense mode. We're doing this in collaboration with our U.S. government partners. We're not doing it alone. We're working together. And what we want to bring is a system of systems to put everything out there that works well together and doesn't negate the things that are out there already. We view this as an augmentation of the systems that are existing today.
So can you tell us about the counter-electronic high-power microwave extended range air-based defense system? It's known as CHIMERA, if people didn't know that. What are its capabilities and applications, and how does it fit into this scenario?
Yeah, so CHIMERA is a ground-based demonstration system. As I mentioned before, it's built to fire highly concentrated RF or radio frequency energy at multiple targets. Mid to long range targets, and it's much higher power than some of the HPM systems that we've seen in the past. It's a standalone system we developed with the Air Force Research Lab, and it works much like any other HPM or microwave system. We take a low average input power and we compress it down to very short pulse durations using pulse power subsystems, and then we convert those pulses to microwave energy using RF source subsystems, and then we take and emit that energy into free space using the antenna. The analogy here would be, filling a balloon really, really slowly through a soda straw and then releasing it all at once by popping it. that's essentially what our pulse power system is doing, except we're doing that with electrical energy in a very controlled and very repeatable way. That energy we then convert to microwaves in our RF sources, and we emit into free space and direct them at the threat that we're targeting using our antenna. The high power microwave and other non-kinetic systems such as lasers, we see as a part of the layered defense strategy that the U.S. is employing. I mentioned before, they're cost effective in that they operate at the speed of light and really only use the power inside your generator, as opposed to firing a kinetic effector at the inlets. The way they work on the target is by attacking the electronics within that target. An analogy would be to take your cell phone, put it in the microwave. There's going to be lots of sparks. And when you take it out, it's not going to work very well, if it works at all, when it comes out. So that's essentially what we're trying to do at targets that are very, very far away. And that's why we have the large antenna on top to project that energy out and target it at the incoming threats. Ultimately, we want to allow our warfighters to defeat incoming threats quickly and in cost-effective ways. If you look at the threats that we're going to see, that we are seeing, there are large raids that come in. Use, for example, if you have 20 incoming threats, if we put a system like this out at the front line and use it first, and we're able to disable even half of those threats, that's 10 things that our air defenders no longer need to track, pay attention to, and ultimately engage with some type of effector.
And it's great. You don't need to reload it. You're not hitting it with $200,000 missiles that you have to keep replenishing. Can you describe how the CHIMERA test went? What were some of the objectives going into the test, and what did your team achieve?
Yeah, so in cooperation with the Air Force Research Lab and the Navy, we successfully completed a 3-week test of the CHIMERA system out at White Sands Missile Range in New Mexico. We were very pleased. The system performed exceptionally well. During the test, we had the goal of applying directed energy to static target variations that we put out there to fire at. And really what we were looking for was the repeatability and the predictability of what the RF energy applied would do to those targets. And we're happy to say that we saw exactly what we expected in those testing. Second goal of the test was to demonstrate the end-to-end fire control, and we were successful in doing that also by acquiring and tracking the airborne targets that we had out there, and we maintained that track throughout the entire flight. The other piece of this that we were really, really proud of is the system showed really good ruggedness out in the desert. It stayed out in the desert environment for well over a month, and faced adverse conditions. There was wind in excess of 60 miles an hour. There was rain. And the system was able to survive through all of that and work with minimal upkeep while it was out in the field. We were really, really proud of that. And as Dr. Welsh, the director of AFRL-RD, highlighted, this test really shows the power of industry partnering with government to address warfighter needs.
So how have you addressed the reliability and mobility of these systems in general?
Yeah, that's a good question. So that's really the key with any new technology. First we need to show the viability of that technology, and then we need to make sure it's robust enough to be deployed. And as I mentioned before, we're really proud of the way that CHIMERA performed out in the desert and in the environmental conditions that it was facing. The challenge we face with this technology is to have the effects at far enough range that the air defenders have time to assess whether or not it was effective. And if they haven't been, they can then fire a kinetic capability at it. So range is really one of the challenges that we focus on, and it's what we fight with microwave energy. We're working closely with our customers and the government labs to ensure that the systems are easily usable and maneuverable for the specific environment they need to be used for. And really the challenge there is swap, size, weight, and power. So what we're doing with the learning that we had out of the field with CHIMERA, we're taking some of that data and we're using that data to guide the development. And as we look to the defend effort, we really want to use that to improve upon these systems, make them more rugged, make them more reliable, and get them down into the swap that they need to be fielded. again, I'll highlight the need here for continued funding of these tests and these opportunities for learning. They really drive the development in a positive way for our warfighters.
So, what other types of high energy microwave systems is RTX working on, and what applications do they address?
Yeah, so Raytheon, we have a long history of developing and manufacturing all types of microwave systems, radar, electronic warfare, communication systems. From a directed energy perspective, right now we're really focused on taking the learning from CHIMERA and applying that to the two high power microwave prototypes under the Defend program in conjunction with our partners. We're on target to deliver that prototype hardware to our customers in 2024, and then again the second system in 2026. And these systems really are looking at the airborne threats in a layered defense architecture. That's really been our focus right now. And then taking those prototypes and integrating them along with our government lab partners, integrating them into prototype demonstrations to further the goal of getting them fielded and in the hands of our warfighters. The other piece that we at Raytheon are focused on is how do we use these in conjunction with the systems that are already out there? If we take and hand our warfighters, our air defenders, new tools that they aren't properly prepared to use, or they look completely different than what they already have, it's not going to be all that useful. So we really need to make sure that we integrate them with things that they're comfortable with and in ways that they can pick them up and use them.
And so, how has what we've seen in the Ukraine-Russian war affected the design of these systems? Because there's a lot of electronic warfare and drones and things that have been in the news. So I'm wondering how that worked.
Yeah, I think if you look at current world events right now, and for the most part, that's really driving the need for these and the demand signal for things like directed energy. They provide air defenders, depth of fire, and that's really where HPM shines in the depth of fire and the cost per shot. I mentioned before, these are intended to be frontline systems, augmenting our other defenses. As we look at HPM and for that matter, lasers and kind of any types of directed energy, we look at these not as a replacement for the kinetic effectors and the missiles that are out there, but really an augmentation. We at Raytheon have been a leader in high power microwaves and in microwave technology for a long time. And our engineers are really expert at looking at these kinetic and non-kinetic defense systems and trying to figure out where the layers make the most sense to put these in. What we've looked at, in particular with these systems, is take the first shot and as many shots as you can with an HPM or a laser. And the word we use is kind of trying to thin the herd of what's coming in to preserve our kinetic effectors for future raids or for other purposes.
Yeah, that all makes very good sense. What are some of the future developments you see coming in the next few years, looking forward?
Another good question. Like many other programs, SWAP, as I mentioned before, is something that comes into play as you try to field these systems. The smaller they are, the less they weigh, and the less power they take, the more easy they are to deploy. And so as we look to the future and what future developments, we really want to shrink those down and make them more deployable and get them in as many places as we can. And along with that comes cost, right? And you want to get the cost down to make them as cost effective as possible. Our focus, as we look at these systems now and these new tools, is to put them in, drop them in, and make them as compatible with the systems that are out there. And that also goes to the swap, right? If we can make them smaller, they take up less space and they're easier to drop in with existing. I'll say the last piece of development that we see coming in the future years is as the threats evolve, and we see different types of aerial threats, different types of electronics in those threats. We need to be continually iterating our systems to be able to quickly and effectively disarm those threats. So we do a lot of work in looking at what's going to be most effective and then employing that in our systems. And I think that's where the future of this technology.
Well, thanks, Paul, for talking with me today about Raytheon's history and your current work in the high power microwave systems and their applications area. We hope to circle back with you maybe after the contract and check in on more results. That would be great to do. To our audience, you can find more podcasts at podcast.microwavejournal.com. Thanks for listening.